In this lab, you are supposed to develop an online version of the fault detector that you have developed during the previous lab assignment. To be more specific, instead of collecting and shipping sensory data to the backend system and training a large neural network, we are going to train multiple smaller online local neural networks at our edge nodes. Here, for every measurement that we collect from our sensors, we are going to train our local neural network on the spot for one or several epochs. So let's open the folder for this lab and look into its files. I have updated the EI fault detector file and added a class called Fault-Detector-Online. Similar to its offline version, it holds a neural network that it would train and use. In the EI nodes, I have added another data structure called fault data points to mark the faults edge nodes find. I also added another function to the edge node class to detect faulty sensors. The main sensor is the same as before. I have also updated the main edge.jl. I have added another dynamic web page to show faults using EGS web pages. I also added this section to periodically call the detect faulty sensor functions on the edge node with the default interval. So let's look into the test file. So this is how I'm going to program my edge node to detect faults every 500 milliseconds and mark a measurement faulty if it is more than 10% apart from what the neural network suggests. So let's compile the project and see how it works. So let's update the package.json as well. I need to open another terminal. So now let me run the sensors and the edge. And now let's test it. If I go to the main web page of the Edge node, like before, I would see the data points, I would see the combined data points, and I would also see the fault points. Like before, I can see the graph for all sensors. And I can also see the faults. Here, as you can see, I only detect faults for one of the sensors. And the bold line is what the sensor actually produces. And the thinner line is what the neural network predicts for the sensor. And as you can see, if it's apart for more than 10%, it will be marked as a faulty node. If I go to the test file again, you would see that I would run this for 60 seconds. So let's try this one more time. This time I'm going to go to the fault page directly. As you can see at the beginning, the neural network is really off, but gradually converges to the sensor reading, and it actually learns what the sensor should produce. After a while that it converges, it would not mark the sensor reading as faulty anymore, only those that are apart for more than 10%. Such as this one. So your task for this lab assignment is to complete this section, as well as write these two functions. In the main edge.js, you also need to update this function to show faults for all sensors.